To understand how a wastewater treatment system works, first we need to understand two important concepts. Firstly, what is wastewater? Secondly, what is our goal when treating it? Household wastewater is made up of water and solids. Water comes from the washing machine, sinks, showers and toilets, with solids coming from human waste, food, grease and fats, soap and other organic matter. It's full of bacteria and viruses. Every year, there are over 500,000 deaths from waterborne diseases such as dysentery, typhoid and cholera. Globally, at least 2 billion people use drinking water from a contaminated water source. Our goal when treating wastewater is disinfect the wastewater, remove deadly viruses, and ensure it can enter safely back into the environment. In traditional systems, there will be no disinfection or filtration of solids and limited treatment. Upon disposal, these bacteria and viruses are trapped in soil, which is subsequently treated as toxic waste, eventually needing to be dug out and put into landfill, essentially the wastewater equivalent of single-use plastics. Nowadays, bacteria is part of the solution when treating wastewater, by activating it to consume nanosolids in what we call a water polishing effect. Combined with a few other steps to achieve nitrification and denitrification, we're able to reintroduce clean water back into the environment safely. Instead of toxic waste, we now have fertilizer that can be reused for agricultural purposes and disinfected water that is used for irrigation and then enters safely back into the natural water cycle. The Tail-X ABS-NR wastewater system achieves this using a 5-chamber process. Starting with the physical treatment process. The first 2 chambers essentially act as a septic system, where solids are separated. Plastic, oil, fats have a bulk density lighter than water and float to the top. Solids with a heavier bulk density than water sink quickly. Very small solids don't fall in time and transfer to the next chamber for further treatment. Next is the biological treatment. In the 3rd chamber, oxygen is pumped into the water, transitioning treatment from anaerobic to aerobic. This creates an environment where healthy bacteria become active. If we think of bacteria like fish, the amount of oxygen in the water impacts their activity. High oxygen fish are stronger, more active and hungrier, and as bacteria get stronger, it polishes the cloudy water by consuming all the fine particle solids. This process causes a high level of digestion and decomposition, with bacteria continuously digesting and condensing solids. Within this step are many other reactions, including those that assist with binding phosphorus in the water and removing nitrogen, all within a natural, chemical-free biological process. Bacteria play an essential role in the aerobic phase, and without them, we couldn't achieve sufficient levels of treatment. Don't be fooled, some systems claim to handle higher levels of toxic substances, such as antibacterials, bleach, and other chemicals. We know that if enough toxic chemicals are in the body of wastewater, the bacteria will simply die off, and the system will no longer operate as it should. Filtration and recirculation are next. The water enters a very still and calm clarification chamber with no oxygen. This causes bacteria to become dormant and sink to the bottom, waiting after consuming all the solids. The resulting dormant bacteria are recirculated to the first stage of treatment, while the water exits the clarification chamber through the TFC. Similar to a dam weir, the TFC holds back the water, only letting a small, constant amount through. It also limits turbulence, preventing unsettling solids from one chamber to the next. Disinfection is the final step. For over 100 years, chlorine has safely and reliably disinfected drinking water. Thanks to the controlled flow of water entering the chlorinator via the TFC, we are able to precisely control free available chlorine, FAC levels, keeping it at 1.04 parts per million, the same levels found in our tap water, disinfecting 99.99% of bacteria without harming the environment. As the disinfection chamber fills up, the float switch on the pump is activated. The water is now ready to return to nature. The treated water is pumped to the land application area, where it safely rejoins the water cycle through evaporation, transpiration, and infiltration. Talex, the wastewater specialists, trusted since 1969.